we're looking at how to find probabilities for normal random variables. Here we said that like for other continuous random variables, we can't use the PDF or the CDF because we can't integrate the PDF of the normal random variable directly. So we said instead we have Z tables, which can be used to find the probability of standard normal random variables and in general for any normal random. We will first look at how can we find probabilities for a standard normal random variable using the Z table. We'll first look at standard normal random variable, then we look at data in general for any normal random variable. So now the Z table that we're going to use are the different Z tables that are available. The one that we're going to use is going to be the one that has CDF values for positive values. So here when we say CDF values, so this means it gives us the probabilities ZS less than equal to Z, right? It's giving us these probabilities, right? So this Z table that we're using gives us CDF values, i.e. it gives us probabilities that are the form probability Z is less than equal to Z. And it does that for positive, and it gives us those values for positive and gives us these CDF values for positive values of Z. So what about if we have a negative value Z? Say you want to find, say we are interested in the probability Z is less than equal to say minus 0.8. How do we find this, right? Because the Z table only gives us CDF values for positive values. So see, what if we have a negative value Z? We want to find the probability Z is less than equal to some negative value. So for that, we'll use the symmetry property of normal distribution. And let's recall what the symmetry property is. It says that the PDF is symmetric around the mean, and in the case of standard normal random variable, that mean is 0. So now when you want to find probabilities for a standard normal random variable using the Z table, we'll do it in a two-step process. In the first process, we'll make sure that we only have positive values of Z. If there are any negative values of Z, we'll use the symmetry property, right? So remember, the table only gives us CDF values for positive values of Z, right? This is what the Z table gives us, right? It only gives us CDF values for positive values of Z. So in the first step, we'll ensure that we only have positive values of C. Once you only have positive values of C, if any probabilities in this form, probability Z is greater than some value plus A, right? Because we know the Z table only gives us CDF values, so we'll write this greater than in the form of less than equal to, and for this we can use a complement, right? We write this in terms of CDF of Z, for which we can use a complement rule, right? And then you can read this, and then from the table you can get this CDF out. So in second step, we make sure we only have probabilities in the form of CDF of Z. So when you want to find probabilities for a standard normal random variable using the Z table, just keep in mind the table that we're using only has CDF values for positive values of Z. So in the first step, you ensure that you only have positive values of Z. If you don't have that, you can use the symmetry property. In the second step, so using complement rule. So we'll use complement rule here. Right, in the second step, once you only have positive values of Z, if any probability is in the form probability Z is greater than some positive value, so we know the Z table gives us probabilities of the form probability Z is less than equal to some positive value. So what we'll do is we'll rewrite this in terms of CDF of Z using the complement rule, and then we can read that from the table. So let's look at a example question for that. Just a second before we bring in the Z table. So we said, now let's first start and see how can we find probabilities to the left of the Z value, right? So let's start with that. So let's start with finding probabilities to the left of the Z value. So here we look at two examples. One, probability Z is less than some positive value, then probability Z is less than some negative value, right? Probability Z is less than equal to 1.96. Now here the probability that we want to find is in the form of CDF for some positive value Z, because remember the Z table that we have, it gives us probabilities, it gives us the CDF values for positive values of Z. So this is already in the form of the CDF of a positive value Z. So this is essentially 1.96. Because remember, we said that for standard normal random variable, we can denote the CDF instead of FS5. If I just plot this and I see graphically how this is, so we know this is the CDF of a normal random variable, which in this case is centered and symmetric about the mean. So, and then this is 1.96 somewhere here. So this area is what we want, right? This area is probability Z less than equal to 1.96, which is 1.96. 1.96. Now this we can directly read from the table. Why can we directly read this from the Z table? Because this is already in the form of CDF of positive values. Remember, the Z table we're using gives us the CDF values for positive values of Z, right? So this is already in that form, right? See, it's already in this form, right? This is the CDF. It's giving us probability Z is less than equal to some positive value. Since we already had the probability in the form, we can directly read it from the Z table. So here, we know these are the Z values. Let's see how will we read it. If I just go a little down. So we are interested in, let's just see what do we want. We want probability Z is less than equal to 1.96. So the Z value is 1.9 here. And okay, so let's just move. Okay. So this is sorry. So this is 1.9 here. And then we know in the decimal place, we want 1.96. So this is how we read it. We want probability Z is less than equal to 1.96. So the Z value is 1.9. And then we choose a decimal from here, it becomes 1.96. So essentially what we are interested in is this. This is the area, right? So the Z table gives us a CDF values for positive values of Z. And what in this, the first part what we were finding was already in the form of CDF of positive values Z. So we can directly read it from the table. Choose the Z value from here. So here we can see it's 1.9, 1.9, and then we can choose the second decimal place from here, 1.96. And so this is the probability. So this is essentially giving us this area. So this is giving us this area for Z is 1.96, right? For Z is 1.96. This is telling us this probability Z is less than equal to 1.96 is 0.975. Right, so this is just 0. So this is sorry, so this is just 0.975. So simple. So now let's do a second part related to this, where we still want to find the probability to the left of Z. But now instead of probability Z is less than equal to 1.96, we want to find probability Z is less than equal to minus 0.96. If you go back to the Z table, like we said, the one that we're using only has CDF values for positive values. Like see here, it starts giving you CDF values starting from value 0 up till 3.3. Right? It doesn't have CDF values for negative values. And like we said, whenever we have negative values Z, if we go back, we said the first step is going to be, so we said the first step is going to be that we're going to convert any negative value Z. We're going to, for any negative value Z, use symmetry property to get it in terms of positive values. So see, that's what we're going to do over here. Right? So like we know, K. So whenever you see a negative value, first always use symmetry property to get a positive value, right? So Z table does not have CDF values for negative values. Sorry, for negative values. This is in the form of a CDF, right? We know the Z table that we're using gives us CDF values, but it gives us for positive values of Z, not for negative values of Z. So although it's in the form of a CDF, but it's a CDF of a negative value Z, so we have to convert it into positive values. So use symmetry property. And symmetry property, what does it say? It says that normal random variable speed is symmetric about its mean, and in this case, the mean is 0 for standard normal random variable. So use symmetry property of normal distribution. So how will I use that? Let's see. So let's draw the PDF. Let's graphically illustrate this. This is Z. This is Z. What we're interested in is this. This is minus 1.96. This is the area we want. So this area is probability Z is less than equal to minus 1.96. Now the idea is this. By the symmetry property, because it's symmetric around the mean, which in this case is 0. So this means the left-hand side and right-hand side are mirrored images of each other around centered at 0. Right? So probability Z is less than minus 1.96 by symmetry is the same as this area. It's the same as probability this area, right? So essentially we want this area, right? So if I plot this again below this, right? I'm sorry. Let's just make this nicely over here. Right, so if I make this again, this PDF, right, this is Z, this is Z. So essentially the area I'm interested in is this, if I look at in terms of, oh, sorry. Right, so if we go back, right, this is the area we are interested in. This area is probability. By symmetry, this is the same as the area we wanted. Right, by symmetry, we wanted this, but by symmetry, we know it's equal to this area, right? So I can say by symmetry, because we know it's always centered in symmetric around its mean, which in this case is Z. This is just probability Z is greater than equal to 1.96. Again, we know for a continuous random variable, whether you write the equal to sign or not, it doesn't matter, right? Because point probabilities are 0, the probability takes a specific. So by symmetry, I have written it in terms of positive values, right? So we know if we had a negative value z, we know that it is in the form of a CDF, but the table only gives us CDF values, so positive values z. So we see a negative value, we write it in terms of, we use the symmetry property to write it in terms of positive values. See, now we've done that, right? We have it in terms of positive values, you see, but now there's another issue. It's not in the form of CDF anymore. Initially, it was in the form of CDF, but there was a negative value. So we use symmetry property to deal with that issue because the Z table only gives us CDF values for positive values. Now we do have a positive value, but there's a new issue that this is not in the form of CDF or Z. We have a greater than equal to, where the table gives us these values. Phi Z is probability Z is less than equal to Z for positive values. So now what we're going to do is we have to rewrite this, right? Now the problem is that the Z table only has CDF values for positive values. Sorry, positive, we can just ignore that because we've already done that. Sorry, Z table only has CDF values. So now rewriting this in terms of CDF. So now I want to rewrite this in terms of CDF. And for this, we'll use a comp, which we can then read from the table, right? Because we'll finally have it in the form of CDF for positive values. Because remember, the table has only CDF, CDF values of positive values of Z. So first, it was a negative value. We rewrote it in terms of positive value. But now it's no longer in the CDF, so we can use a complement rule. And we know we want to find probability Z is greater than 1.96, which by the complement rule is the same as 1 minus probability Z is less than 1.96. And now we can just read this value from the table. So now read from Z table. Right, because this is in the form of now CDF for positive value Z, the table has this, right? And this we just found in the earlier part. So we can just take that from there. So this is 1 minus, this we found in part 1, 0.975, this probability. So this just turns out to be 0.05, right? Because see, now finally it's in a form that can be read from the table because it's in the form of a CDF value and a CDF value, positive value. So if you see a negative value of Z, so the first thing you should do is you should use the symmetry property and write it in terms of a positive values. And after that, we did that, we had another problem now. The table only has CDF values. It was not in the form of a CDF. So what we did was we rewrote it in the form of CDF using the complement. And then you could finally read this from the table.